Hello everyone, this is our 26th video tutorial under the GCSE topic revision called 3D Pythagoras. We have discussed the 2D Pythagoras in our 25th video tutorial where you can apply the Pythagoras theorem on a two-dimensional diagrams. Now we are going to learn how the 2D effect can be extended to three-dimensional solid, cuboid and square-based pyramid, things like that. There's no theory or additional thing you need to remember compared to the last topic. On the tutorial time, when we are doing the exam style questions, I will discuss how we want to visualize and how can we apply the Pythagoras theorem to the 3D shapes. Let's look at some exam style questions. This is the tutorial we are going to discuss in this video session. If you like to download this tutorial, please refer to the link in the description below, or you can download this from our website at www.smart-tutors.co.uk/worksheet.php. Under the E11 section, you can download this tutorial. Let's look at the question now. Question number 1. So question number 1, the diagram shows a cuboid. Find out the length of D. The D is the diagonal of this 3D shape. So the reason why this topic is categorized as a level 8 and level 9, little bit harder, only because of this is an imagination. You need to visualize and imagine this 3D shape, how this 3D the triangle is going to be constructed. Let me explain this one. So I'm going to use a different color. Let's use a red color to stand out more. I'm going to draw diagonal of the bottom rectangle. Let me do it neatly. So this is the diagonal of the bottom base, and if I draw the diagonal D again, and if I draw the perpendicular line again, right, and now you can see there are right angle here. So the red color is a right angle. If you want to find out the D, you have the 15, you need to find out this one. If you want to find out that one, let's say that is X, you need to find out a Pythagoras theorem for the bottom right angle triangle. So there's a bottom right angle triangle, you apply the Pythagoras theorem, which is a 2D Pythagoras. We already discussed in the tutorial number 25. 6 squared plus 10 squared. So x squared equal 6 squared plus 10 squared. So I'm going to keep this as x squared 36 plus 100, which is 136. Don't try to find out the answer for the x. Keep it as a x squared because we need that on the next step. So the next step is for the right angle triangle, which is x squared plus 15 squared equal d squared. Don't make any careless mistake. Always the opposite side for the right angle is the one standing on its own. So the d squared is the hypotenuse standing on its own. Then that is one side. 15 squared and x squared is the other side. X squared you can replace it with 136 plus 15 squared equal d squared. So d squared equal 136 plus 15 squared is, and remember, is 225. And d equals square root of 5 plus 6 is 11, 361. So if I open my calculator, so plus 361 and square root is 19. So the answer for question number 1 is 19. There's no dimensions given, so if it is centimeter, it's going to be 19 centimeter. So if this is, assume this is centimeter, or if there's no dimension, leave it like that. But there's a, because this, I just made this question up, so assume there's a centimeter there, so 19 centimeter. So I wanted you to try to understand where the concept coming from, right? It's actually, I'm applying the 2D Pythagoras theorem. There's nothing more additional theorem you need to remember, but you need to apply the 2D theorem twice. One is for the first bottom base and trying to find out the x. Again, keep the answer in x squared, because which is an input for the second Pythagoras theorem. And secondly, apply the second Pythagoras theorem for the right angle triangle standing like a diagonally. Right? That's all for the question number 1. Question number 2. So the question is a little bit tricky now. This is a square, it's not a square, triangular prism. Right? So triangular prism is this one. First of all the measurements are in centimeter. So these all are in centimeter. Right? Now find the length of HG. HG. All right. Okay, HG, let's look at this triangle. HG, so if I do this one like that, and this is the H, this is the G is in question, and that is a right angle triangle, that is 15 is given, this is 20 is given. So that is an easy question. How to do that one? So 20 squared equal 15 squared plus HG squared. So HG equal square root of 15 squared, sorry, it's my bad. So 20 squared minus 15 squared. So that is the answer for so basically let me find out that one. So square root of 400, assume this is non-calculator, 400 minus 225. So this is going to be square root of 175. So 175. So I'll leave it as it is, or if you want to simplify also can. So I leave the HG as a square root of 175. If they ask in a decimal place or something, you can make it as a 2 decimal place, or they didn't say anything. So the best way to do is I leave it in a surd format, or you can do like a 13.23 for 2 dp or something like that. Right? Now find the length of EG. Find the length of EG is the bottom one. So if the bottom one, let's say, I'm going to draw another triangle for understanding a little bit better. So the triangle is like that, and now E is here and G is here and F is here. So FG is same as 15 and EG we don't know and EF we don't know, right? And now, so this is the wrong triangle I have drawn. So now trying to think which triangle will help me to find the EG. So the triangle on the surface, this triangle, if you think, right? So if I draw that triangle, so if I draw like that, and this is 7, that is HEG. HG is known, EG is the question mark. So HG squared equals 7 squared plus EG squared. Now HG squared, I know HG is square root of 175. HG squared is 175, isn't it? So 175 equal 7 squared is 49 plus EG squared. So EG equal square root of 175 take away 49, which is 1, I think 126 square root, which if you like you can press the calculator. 126 square root, which is 11.22. So 11.22 for the 2 decimal place. Question number C part of the question number 2. Find the length of EF. So EF is the diagonal of the bottom triangle, which is the one I tried to do it before. So now let me do it. Yeah, so this is the way I need to draw. E here, G here, F here. The question is EF is question mark. EG is, I put a tick, which means I already know. So here EG is here. And GF is same as 15. Because this length 15 here same as this is 15. Now apply the Pythagoras theorem. So EF squared equal EG squared plus GF squared. So EG squared, I'm going to apply 126 because it's a square root. EG squared is 126 plus GF squared is 15 squared. So now EF is 126 plus 225, which is square root of 1153. So let me type that in the calculator. So 126 plus 225, let me see that any calculator mistake I do. 126 plus 225, and that is giving, so correct answer we got, and I'm going to take the square root, which is 18.73. So 18.73 to 2 decimal place. So that is the third part of the question number 2. Question number 3. VABCD is a square base pyramid. Side length of 4 centimeter of the square. The perpendicular height is 3 centimeter. Find out the length of the VA. Now here same concept, I'm going to use the red color. So this is the VA, trying to use the ruler to make it a straight line. So this is the VA, right? And this is the VO. And the diagonal, I'm going to connect AC here, right? The diagonal AC, half of the length is AO. So this length equal to this length. So AO equal to OC. So first of all, I need to find out the length of AC. So AC is the question mark now. It's a square base pyramid. So this is 4 centimeter, 4 centimeter. So AC squared equal 4 squared plus 4 squared. So 4 squared we know is 16 plus 16 is 32. So AC equal square root of 32, right? So square root of 32, we know third, 16 times 2 is 32. Square root of 16 is 4 root 2, right? So half of AC is AO. So AO is half of 4 root 2, which is 2 root 2. So if you think the 2 root 2 is the length of this one, and this is a right angle triangle standing up 3D. So if you have any problem visualizing, I'm going to draw a triangle to give you a little bit of more explanation here. The height is 3 and this is 2 root 2 and this is my VA. So all they are asking is what is VA? So VA squared equal 3 squared plus 2 root 2 whole thing squared. So 3 squared is 9 plus 2 root 2 square is 2 root 2 times 2 root 2. So that is the answer. 9 plus 2 times 2 is 4. Root 2 times root 2 is 2. So 8. So 9 plus 8 is 17 is the VA squared. So VA equal square root of 17. That is the answer for question number 3. Question number 4. The diagram shows Diana's suitcase. The suitcase is in the shape of cuboid. Diana has a walking stick that folds. The folded walking stick has a length of 60 centimeters. So she's trying to put the folded walking stick 60 centimeter inside the suitcase. Diana wants to put the folded walking stick in the suitcase. Will the folded walking stick fit in the suitcase? First of all, the important thing is where the walking stick is going to be maximally located is this diagonal, right? So if we find out what is the length of the red color diagonal D, and the diagonals D is more than 60, yes, the walking stick will fit in. If this diagonal is less than 60, it won't fit in. So in order to find out that diagonal D, you need to find out the bottom base diagonal, and using this height, you can construct a 3D right angle triangle standing straight up. So before I apply any 2D theorem, I am going to use the bottom triangle, the 3D shapes, the bottom triangle. Let me shade it, then you can see this right angle triangle is the base right angle triangle. 20 and 45 is given, so you can label this as a B. So let me find out the AB squared. AB squared equal 45 squared plus 20 squared. So 45 squared is I think is 225 plus 20 squared is 400, and the answer is 2425, and that is the AB squared. So AB equal square root of 2425. I'm not going to be finding this answer. I leave it as it is. That answer may be useful for the second part. So the second part, AB squared plus 30 squared equal AC squared, which is my diagonal. So AB squared we already find out 2425 plus 900 equal AC squared. So AC equal square root of, so 3325. So 3325 square root 57.66. So AC equal 57.66 centimeter. So that is the answer for AC. So the 60 centimeter, so the folded walking stick, so this is less than 60 centimeter walking stick won't fit in. Right, so that's the answer for the question number 4. Question number 5. Tom is planning to put the pencil inside the cylindrical pencil case. His pencil is 20 centimeter long. Find out whether Tom can put this pencil inside or not. So all what you want to do is, it's a right angle triangle. You can see this one. So x squared equal 15 squared plus 8 squared will give a rough length of the diagonal. So square root of 982. I'm trying to use manually, but when it comes to this one, I roughly know square root of 289 should be. Press the calculator. So 289 square root of, it's 17. Yes, I guess so, 17. So 17 centimeter is the pencil case diagonal length. So this is less than 20 centimeter. So pencil won't fit in. That is the answer for the question number 5. Question number 6. The diagram shows the cuboid AB and BC, CD, everything is given. Find the length of AD. So let me quickly draw the AD length. Then the same concept what we are discussing is you need to draw the base diagonal and connect with the perpendicular height. And now you have a right angle here and you have a base right angle. Start with the base right angle and find out the AC. So AC squared equal 10 squared plus 2 root 11 whole thing squared. And that will give the AC squared. Keep it as it is, 100 plus, careful, don't make any silly mistakes on this one. This one is 2 root 11 times 2 root 11. If you have a little bit weak on certs, please go back to the certs tutorial, and it's tutorial number 17, I think. Revise yourself, make confident, because cert format questions can come on any type of question. It can come on trigonometry, it can come on algebra, it can come on Pythagoras theorem, something like that. So you have to have a thorough knowledge on certs. So 2 times 2 is 4, root 11 times root 11 is 11. So 11 times 4 is 44. So the answer for AC square is 144 is the answer for AC square. Now apply the Pythagoras theorem diagonally. So AD squared equal AC squared plus CD squared, which is 5 squared. So AC square is 144 plus 25. This is 169. I know AD is 13 because square root of 169 is 13. So that is the answer for the AD. Question number 7. ABCDE is a square base pyramid. The apex of the pyramid E, this is the apex, and is directly over the center of the base. Calculate the perpendicular height. So they are asking the perpendicular height of the pyramid. So if I connect here to here and like this, right, so this is the right angle triangle, or you can put it other way around. So this 12 centimeter is marked. So this is the right angle triangle, and the bottom one also right angle triangle. It's a square base, so it is 10 centimeter. So AC squared equal 10 squared plus 10 squared. So 100 plus 100, and AC squared. So AC equal square root of 200. So that is 10 root 2. Right, AC equal 10 root 2. So AC 10 root 2 means if I put O this one, OC is half of AC, so which is 5 root 2. So this is 5 root 2. So we can find out the perpendicular height OE. So if I put height H squared equal 12 squared minus 5 root 2 squares. Right. So this is 144 minus 5 square is 25, root 2 square is 2, so that is going to be 50. So 144 take away 50 is 94. So H equals square root of 94. They didn't ask what format they wanted to give. Let me press the calculator. 94 square root is 9.695. So 9.70. So 9.70 for 2 decimal place. That is the answer for question number 7. Question number, I think that is the end of the tutorial. So I hope you like the video. As nothing much you need to know from the previous tutorials. So only thing, learn how to visualize the 3D shapes and apply the Pythagoras theorem twice or 3 times. It doesn't matter how many times, as long as you understand which one is hypotenuse side and how the right angle triangle is standing up and which diagonal you need to measure or find out using the 2D Pythagoras. That is the end of the tutorial. I hope you like the video. If you do like the video, please click the thumbs up button below and subscribe to our channel. If you have any friends need some help in the maths and they are taking GCSE this year, please forward and share the links and share the knowledge, and they can get the benefit also. Thank you so much for your help and watching this video. Thank you.